Over the next 40 million years, temperatures oscillate and ice sheets repeatedly grow and melt. 125,000 years ago, the ice sheets are on the retreat. Huge amounts of water that had been locked away in the ice surge back into the oceans. Sea levels rise sharply. The oceans flood the continents, submerging coasts, drowning entire islands. It's a watery nightmare. But could it happen again? Back in Florida, Kevin Helmley is hunting for evidence of the massive meltdown in Windley Key Fossil Park. He's fascinated by a remarkable discovery that was uncovered when the site was a working quarry. Towards the end of the last century, laborers cutting slabs of building rock from the quarry unwittingly reveal a critical slice of climatic history. These quarry walls, hundreds of yards from the coast, are the ancient remains of a coral reef. This kind of tropical coral only lives between 10 and 20 feet below the water, making it a valuable indicator of sea level throughout history.
We know that these corals are about 125,000 years old, and as we're standing obviously above sea level, we know that sea level was much higher back 125,000 years ago. We would estimate that the sea level was probably around 10 feet above our heads right now for these corals to have been growing.
This means that 125,000 years ago, melting ice caps must have pushed oceans to 20 feet higher than present-day levels. Scientists calculate that temperatures were 9 degrees Fahrenheit hotter than today's. But what caused the world to warm and the oceans to rise? It's a question that's puzzled scientists for centuries. Then in the mid-1800s, geologists make a remarkable discovery. The polar ice caps had grown and melted repeatedly over the past 2 million years, swinging the world in and out of cold periods. But they have no idea what triggered this relentless cycle of thaws and freezes. Until 1864, when James Kroll, with virtually no education, comes up with a shocking theory. He suggests the answer lies not on Earth, but in outer space. Kroll argues the gravitational pulls of the sun, moon, and planets affect the tilt of the Earth's axis, changing the shape of the world's orbit around the sun, moving it from a circular to an elliptical path. He observes that these changes happen in regular cycles lasting thousands of years, altering the amount of warming sunlight that hits the surface of the Earth.
James Kroll took equations that had just recently been successful at predicting the existence of Neptune and used them to predict that the amount of sunlight upon the Earth would change in a predictable manner.
Kroll's theory is simple and brilliant. When the Earth's orbit is most elliptical, we experience extreme seasons, and the ice sheets grow. But the academic establishment dismisses his ideas, and his papers are left to collect dust. Fast forward 50 years, and a Serbian civil engineer re-examines Kroll's work. Milutin Milankovic pores over his calculations. His conclusion: Kroll was right. And Milankovic goes one step further. He adds a timescale, calculating that our planet changes its orbital pattern around the sun every 100,000 years. This explains why the Earth oscillates between hot and cold periods. But Kroll and Milankovic's calculations were theoretical. Now scientists are discovering concrete evidence of these cycles in another quarry, a few miles outside New York.
This quarry is a wonderful place to see the effect of changing climate, cyclical climate, on sediments and in environments. In this quarry we can see layer after layer of deep lake sediments.
This is a cross-section of an ancient lake bed and it contains a vivid record of the Earth's changing temperatures. The bands of different colored rocks in the cliff face testify to thousands of years of climate change. Each time the Earth's axis tilts or the orbit changes, it alters the amount of warming sunlight hitting the surface. This process has a direct effect on the lake. The more sunlight that hits the Earth's surface, the higher temperatures climb, and the more the lake evaporates. Dry, dusty soil builds up, forming a light-colored layer of rock. Then the Earth's position changes again. Less sunlight hits the surface, and our planet cools. The waters return, refilling the lake. Sediment accumulates on top of the old layer of dry, dusty soil, forming a darker band of rock.
During wet times, such as when this black layer was being produced, we would have seen an enormous lake. So we would have seen nothing but water in this area. But then all that water dried out, and there was a vast, extraordinarily flat plain that was the bottom of this dry lake. This happens over and over and over and over again.
Olson believes these layers in the cliff face are proof that Kroll and Milankovitch were right, that our climate goes through regular cycles of hot and cold. Until 125,000 years ago, the Earth's orbit was nearly circular. Since then, it's shifted and become more elliptical. This means we should be cooling. But instead, our planet is warming.